The Earth's history is described using epochs. For instance, the current geological epoch is widely referred to as the Holocene. It began some 11,000 years ago after the Ice Age, but there is a lively debate about whether, in fact, we're in another epoch, one likely begun in the last century. It's called the Anthropocene and meant to mark the permanent impact humans have made on the planet. And a tiny lake in southern Ontario might just become a critical proving ground for those making the case. With us now to explain, in St. Catharines, Ontario, Francine McCarthy. She's a professor of earth sciences at Brock University and a member of the Anthropocene Working Group. Professor McCarthy, it's great to have you on TVO tonight. How are you doing?
Oh, I'm doing well. Great to be here.
Pleasure to have you. What is your definition of the Anthropocene?
The Anthropocene has many different definitions depending who you speak to, which was one of the issues that the Anthropocene Working Group decided to tackle in 2012. It originated as a term in the year 2000 when atmospheric chemist Nobel laureate Paul Crutzen got up at a meeting and suddenly said, let's stop saying the word Holocene. Humans have so changed the planet that we're now in the Anthropocene, anthropos meaning human. So in 2012, a group of stratigraphers, geologists who study geologic time and the layers of rock and how they record our Earth history, decided to tackle this problem and decide for everyone, once and for all, everywhere around the world, where there is that line that we can draw on the time scale. And basically bring an end to the Holocene and the beginning of the Anthropocene. So the term then was used very loosely until this group of geologists decided to tackle it. And after some discussion, by 2019, it was decided that the year 1950 or thereabouts should be used. So what I mean, and my fellow Anthropocene Working Group members mean by Anthropocene, is the interval of time since 1950, if we're using Crawford Lake as the example, 1950, when Earth systems radically changed in how they respond to one another because of the change in atmospheric composition due to emissions of primarily greenhouse gases.
Gotcha.
So that's what I mean, and that's what my colleagues mean. And depending on which site gets chosen, if it's Crawford Lake, the year would be 1950. If it's one of the other sites, it could be anywhere, let's say between 1948 and 1955. But the key thing is all of the sites that the Anthropocene Working Group studied, 12 sites in all show a massive response, a massive change to atmospheric change, human-induced atmospheric change, and the way the entire planet responds in the middle of the 20th century. So that's what we mean by Anthropocene.
Okay. Just before we go on and talk about Crawford Lake, I do note that you very generously shared my Anthropocene pronunciation when you first mentioned it, but then in every reference thereafter, you called it Anthropocene. And I have heard others. Well, I've heard both. Which is the right one?
There is no right one. It's like Renaissance. You'll hear different people talk about a term and use their own terminology. Most people I know in Canada and northern US would say Anthropocene. Most Europeans would say Anthropocene. And there's also a bit of a divide between scientists and social scientists, so natural scientists and social scientists. So you can call it Anthropocene, and it's because I am bilingual that I innately mimicked your pronunciation of it, but then I launched back into the way I usually say it.
You say tomato and I say tomato. I got it.
Exactly.
Let's call the whole thing off. Okay. You mentioned Crawford Lake. That's one of the sites that's in contention, but it's not the only one. How many sites are folks like you considering at the moment?
So initially there were 12 sites. So there were 12 groups who felt that they had a geological environment that would preserve this signature, the difference between the human-dominated atmosphere, ocean systems, and before then what we're calling the Holocene. It whittled itself down to 9 sites by the time after 3 or 4 years of study, 3 of the groups felt that they didn't have quite a strong enough case to make. So doing the additional work, which was getting the papers, published in a special issue of the Journal of Anthropocene, the Anthropocene Review, what we ended up with were 9 very meaty, very, very detailed papers with lots and lots of data, all of which show everywhere from a peat bog in Poland to an ice sheet in Antarctica. All of these sites showed a massive change in the way the Earth behaves, the way the Earth responds to those changes in the atmosphere. So there are 9 sites in contention all in all, and through the process of evaluating these, we're trying to come up, we, the Anthropocene Working Group, are trying to come up with the best candidate to put forward to the commission that is going to decide, should there be an Anthropocene, should there not? And that's not our call. Our work as the Anthropocene Working Group is to put the best possible site forward, and another group will then decide, did we make a strong enough case?
Well, one of the sites that you're pitching is Crawford Lake, which is only about an hour and change from the studio. And I'm going to ask our director, Sheldon Osman, to bring up a map. There it is right there. And zoom in, if you would. What makes this site of interest, again, to folks like you?
Well, I've been studying Crawford Lake for decades. And my supervisor was the first, my master's supervisor was the first scientist who really recognized the potential for the annual layers to accumulate in the lake, and that being a perfect, like, tree ring-like record of all of the events that happened at Crawford Lake. So the very, very deep lake, it's actually a sinkhole in the Niagara Escarpment, so like a cave whose roof has caved in, a sinkhole. And so it's 23 meters deep, but it's very small, as you pointed out. You can walk around it in 10 minutes on a leisurely stroll. So it's that depth to area and volume ratio that makes the bottom of the lake not in contact with the atmosphere. So it's completely isolated. Its fancy word is called the monomillennium. It's completely isolated. So in a way, it's like the lake that you see if you visit Crawford Lake and walk around the boardwalk. It's a small lake, but hidden underneath that small lake is an even smaller, very, very deep lake that is not mixing with the rest of the environment. And that means that the layers don't get mixed up, they don't get churned up. And so everything that falls through the water column accumulates and doesn't get messed up, so that you have these perfect, they're actually seasonal. There's the summer layer and the rest of the year. So we have a 2-part annual couplet, if you will, that every year marks what's accumulated. And that includes everything from the anthropogenic impact, the gases, the particles, the atmospheric pollution, as well as pollen, natural things that would naturally be there.
We've got some footage of your team at work. So Sheldon, if you would, let's roll some of that.
Oh, nice. Thank you. All right. Oh, that's great.
Oh man, this is very good.
Yeah.
Oh, now it makes sense.
For what the Stratigraphic Commission has suggested as the base of the proposed Anthropocene epoch is 1950 because of the bomb spike, and I am quite sure, based on previous work that I've done on other cores, that 1950 is right around here. And because I think this very thick white line that I was interested in, I think it was 1945, and so that would be the base of the proposed Anthropocene epoch.
Okay, for those listening on podcast and who couldn't see that, your team is sending these very long, huge posts deep into the core in the hopes of pulling up samples. And you were able to conclude what from the sample that you just looked at?
So because we have these, when we put down a freeze core, we actually freeze the lake bed to that. Basically, there's a slurry of dry ice and ethanol, so that that metal sampler that we put down, it actually freezes the lake bed onto it. So each layer that we see, we can actually go back to the lab and sample it. Like, we can very carefully grab just that one layer, and we can test it, we can process it, analyze it for all sorts of different things. We can look at the chemistry, we can look at the biology, the little fossils, we can look at anything in that layer. And because we can do the exact layer counting like tree rings, we can say that in 1945, such and such was happening. And as it turns out, it was shortly after 1945 that the Earth began receiving fallout from plutonium, from all of the atomic weapons testing, and of course the atomic bombs that were detonated in Japan and previously in the Alamogordo Desert. So it is that fallout from the atmosphere of the plutonium everywhere on the planet, because the mushroom clouds got into the upper atmosphere, and everywhere on the planet received this. And so that's the marker, the primary marker for the Anthropocene. Every site that is a candidate for this golden spike has a strong plutonium record. So you would think that 1945, we would say, well, there it is, we have 3 atomic bombs that we know of. But in fact, it took a little bit longer for the fallout to fall out. And so it's not 1945 that we get the earliest records. The earliest records we get are around 1947, but they're fairly weak. And it's really during the Cold War, when you had all of these various superpowers proving that they had nuclear weapons and detonating them in the Bikini Atoll and so on. That's when we start to see a lot of plutonium. And then by the time that people realized, with the Bay of Pigs and the various near misses that we experienced in the 60s, that there had to be non-proliferation treaties, then above ground nuclear testing was banned. And so we have a peak in plutonium records in 1964. And after that, it declines to pretty much background. So we have an increase that starts shortly after 1945, and then it decreases after 1964. And that pattern of, the rise and then the fall back is the primary marker across all the sites. And we have that at Crawford Lake. Crawford Lake is far from any of the atomic bombs or nuclear weapons that were ever, thrown into the upper atmosphere, but it still captures that signal. And so the plutonium is our chronological marker. It's what tells us the time. It says, okay, this is, shortly after the Second World War through the Cold War, that is what you see, the big plutonium record. But there are other things also, the things that really change the atmospheric composition. So the atomic bombs did not alter in large part the atmospheric composition. What did is the emissions of fossil fuels into the atmosphere and changing the effectiveness, the strength of the greenhouse effect, altering our temperature, making the extremes much bigger, the extremes that we have all been experiencing in terms of natural disasters that we're all very much aware of. The changes in those atmospheric compositions get incorporated into the oceans. They change the pH of the oceans. They have all sorts of secondary consequences that most people don't realize. That most people know about the climate change, but all the other aspects of that atmospheric change are recorded in the sediments of Crawford Lake as they are at the other sites that that various groups have been studying. And that's more important to us as a record of how different the time since the mid 20th century has been compared to the rest of the time since the ice sheets disappeared from most of the continents. That much bigger change is reflected in things like fly ash particles and the various changes that we can record in the atmospheric composition from the sediments that we study. So the sediments record a record. They record what the atmosphere was like at that time. So as I said, if you look at 1945, 1950, 1960, you can reconstruct what the atmosphere was doing. And as I said, the fact that it impacted all other aspects of the Earth system and that the Earth remembers that, the Earth records it, that's why we stratigraphers, geologists who are studying the Anthropocene, feel that it is so different from anything that went on in the last 10, 12,000 years that it should be a new epoch.
We're down to our last minute here, and I want to ask you a bit of an odd question to finish on, and that is normally when something Canadian is participating in some kind of international competition, for lack of a better word, we're cheering for Canada to win. On the other hand, this is a competition in a way to determine how we've dishonored this planet. Do we want to win this?
I think we want to win it in the sense that we're a pretty neutral, non-scary kind of player, an actor on the world stage. So, people can feel comfortable coming to visit the type section, the place where the golden spike is. They can feel comfortable that it's not a scary looking place. As you referred to it, it's pretty. It's quite pretty. It's attractive. It's non-hostile looking. So I think that would help in a sense to make it something that people can just deal with, not be afraid of it and stop thinking about it and bury their heads in the sand, but think that yes, it is an issue. We all accept it, and let's move on. Let's deal with the issue as best we can, because ignoring it isn't going to make it go away. So I think being the poster child for how different the Earth is now compared to before 1950, somebody has to do it. It may as well be us. So if we are chosen as the GSSP, I'm going to make it my mission, my whole team, we're going to make it our mission to communicate this as effectively as possible, not just to scientists, but to people from all walks of life. And that, I think, is important. I think the people at Conservation Halton have been really, really helpful in helping us to communicate that to the public who visit, school kids and so on, and to make the linkages with Indigenous people that, whose record, the longhouses that are at Crawford Lake, that we can actually make some really interesting linkages. So it goes beyond just the science. And yes, we will produce, or we will propose the best possible GSSP to that commission. I do hope it'll be Crawford Lake, but if we're not the best, I will put all of my efforts into two things: making sure that the Anthropocene becomes a recognized epoch on the geologic timescale, but also to keep promoting the really unique and special site that Crawford Lake is, and how great a record its like tree ring-like sediments hold.
And just quickly, when's the committee going to decide?
We're in the process now of deciding. What needs to happen is that one of those sites has to have a 60% supermajority to move forward. And like in any, it's like a political convention, it depends. It will be decided when one site has that 60% supermajority, and it is impossible to predict. It could be this next round of voting that decides that starts next week, 30-day period. We may know when that's over, or we may not. Who knows how many rounds of voting we'll have to go through. We saw that with the Speaker of the House in the US. He took many rounds of voting. So I hope it doesn't go that far. The McCarthy thing, I hope doesn't come back to haunt me.
I was just going to say, Francine McCarthy, your friend Kevin McCarthy didn't get this done very quickly.
No relation whatsoever.
This may take longer than we think. Anyway, Professor McCarthy, it's awfully good of you to join us here on TVO tonight. You're a professor of earth sciences at Brock University. You've been coming to us from St. Catharines. Thanks so much.
Okay, it's been great. Thanks.
The Agenda with Steve Paikin is made possible through generous philanthropic contributions from viewers like you. Thank you for supporting TVO's journalism.